Well, good morning, everybody. Uh, Now, let us continue our discussion on implementation uh, on naive-Bayes classifier design. So, what we were doing, we have already, so with pen and pencil, you are with me, right? So, we have already done this. Each word vocabulary of 5, each word class probability we have figured out and we have kept it here. You see one guy in spam mail got has 0 probability. Okay, so what it is going to do, we are going to see now. Okay, say earlier when it was hello dear, it rightly classified that it is a normal message. Now let us see, we have received another mail and we have the same design. We are trying to predict from the design, from the model, okay, that hello got lottery money. Okay, so again, as earlier, we will have to calculate the score, okay, of the sentence in normal class. Let us try to do that. Okay, so probability, we will have to calculate this, right? 0 j equals to 1 to n here 1 2 3 4, right? 4. So we'll have to calculate this. So we have the table. From the table we can just take these values, okay, and calculate. So what is the prior probability of that class? 6 7 as earlier, okay, times probability of hello given normal, probability of got given normal, times probability of lottery provided is normal, times probability of money is normal. So just you got get those values from here. Remind me 0.5 and whatever is required. Okay? 0.67 times, okay, 0.5 times 0.05 times 0.025 times 0.05, which turns out to be, please cross check, 0.401, 2, 3, 4, 2, 1. Okay. So this is the so now we have calculated that given that what is the score of hello got lottery money what is this sentence scoring for the belongingness of normal class. The score is proportional to, same reason we are, technically I am not writing, it is equal to, because I think you all know, right, what we are trying to do. We are predicting, right, equals to Tx. We discussed that this we are not computing, okay, and just the reason I told in my earlier lectures. So that's the reason we it's a constant, right? So that's why we are writing proportional, okay. Similarly, what is you calculate the same thing for spam. Okay. Hello, got lottery money. If you calculate, it will be 0.33 times 0.25 times 0.0 times 0.4 times 0.25. So, which is equals to 0. Due to the presence of this term. Now what has happened, you see? So due to this, probabilities, individual probabilities are to be multiplied, and now you have assigned a word in spam, which incidentally here got, and which has 0 probability. Okay, and that is creating a nuisance. Means whatever values this might have, right? Whatever spam it might be, the message, the probability of that sentence belonging to spam class will be always 0 because of this. Okay, so it's creating a nuisance, and my naive Bayes algorithm collapsed. Okay, so it is not robust in the present form. Okay, because 0 is a very bad idea. 0 probability, assigning a 0 probability is a bad idea for naive Bayes to work. Okay, so we need to do something. Okay, so what we will do, actually you already know in theory that we will do Laplace smoothing. Okay, so with what is the concept here? So in Laplace smoothing, what we do that in Laplace smoothing, the concept is that you add, let me change the color, you add some value, say alpha, plus 1, 2, 3, 4, 5 alpha. Okay. To each word frequency, right? One, two, three, four, five alpha. So what we did, we incorporated some value to all the words frequency, right? And alpha could be any number, but normally it is taken 1. You can take 2, 3, so depending on how. So what is the idea? Idea is alpha equals to 1 means, so it is now the word frequency has increased by 1. Okay. So this has become 45 now, because this is alpha equal to 1 and alpha equal to 1, alpha equal to 1. So that has become 25, and by doing this beautiful thing, what you have done, you have smoothened that data, okay, and you have pre-processed it. Okay, so this is equals to 1. So now it is 6, 3, 1, see 1. If you decide 1, if you decide alpha value 2, it will be 2. At least now God has some weightage, okay, some frequency I have added. I am With this I am not actually losing much, but I am gaining many things. Now my probability will be something, it may be, no matter, it may be near to 0, but it will be something, and my base algorithm will not collapse. And this is incidentally you have already learned and you are implementing it now. It's called Laplace smoothing. Okay, so you will have to recalculate after Laplace smoothing. Now your database has changed and you will have to recalculate all the terms for normal class. So for normal class, that is n class, recalculate all the probabilities of seeing the words in the modified regime. Okay, so you will have to calculate px1 same, okay, equals to probability of hello given is normal. So if alpha value equals to 1, then it was earlier 20, it will be now 21, and now it will, earlier it was 40, now it will be 45. So you will have a different probability assigned. Okay. Likewise. Zero 0.356. And same thing you will have to do. .067. So since I am confident you are working with me, so if I make any calculation mistake, you will be correcting yourself. So great, I am creating model again, okay, in the changed paradigm. This is so simple. Meaning 3 by 45 067, okay, and then okay, now instead of 5, if it is 20,000, 50,000, so that great formula will give you directly. You will be able to compute. You will have to program it. Okay? It will help you to code your algorithm. Equal to 0, which is after Laplace smoothing, how it will look like. Okay, m equals to 20. Remember, my male sample number has not changed. Okay, training sample has not changed. Okay, so prior will be remaining as it is. Okay, so you are making recipes for running 2 for loop. Okay, and this is indicator function which will calculate your frequency, word frequencies automatically. Okay, equal to 0. Earlier it was like that, plus alpha, say alpha, okay, equals to, it may be 1. So this is your alpha, say equals to 1 in this case. Okay, so this is Laplace smoothing. And then we are noting down here I equals to 1 to m 20 ni plus plus 5 times alpha, right? Okay, so for each male there will be one, for each word there will be one alpha. I have 5 words, so 5 alpha here, or equals to say 5 equals to alpha equals to 1, so it is equals to 5. So this is the number of actually vocabulary. In case 20,000, so it is the vocabulary 20,000, 10,000, so that number will be here. So this is again very simple. So with the, we wrote the earlier generalized formula for calculating the probabilities. The way we have calculated here exactly the same. Okay, so we have 20 samples in the normal class, so outer loop, and inner loop we are counting the word frequency, right? So this is ij. Okay, as many times the word will come across, so that frequency, that one will be there, and this is the AND operator. It means that we are calculating everything for class normal, okay, divided by this total number of words in that particular class. Okay, so we have computed this manually. I have told you how to compute it automatically in a algorithmic way. Now we will have to do the same thing for we will have to recalculate the probabilities. Okay. For spam class. So quickly I will write it down. Six by 25 equals 0.24. Dear three by 25 0.12. Got 1 by 25 0.04. Please note, okay, now this is no more 0, so my algorithm will work. My classifier is safe now. So this is actually very simple Laplace smoothing in practice. Okay, so although it is normally kept equal to 1, but there is no bar, making it high only will increase the probability of that word which may not be correct always. So that is your choice. Okay, that how much value, alpha value, is it 1 or 2? Money 6 by 25 equals to 0.24. So please check or whether 1 or not. Okay, cross check, and then we have in generalized way we have with smoothing, Laplace smoothing, generalized way of computing the same thing which I computed. We'll have to create 2 loops. Provided this is your spam class plus alpha, say alpha equal to 1, then it will be 1. So making yourself habituated with this very simple concept of indicator function is good, because now it will enable you, at least our student I believe, to develop this vocabulary. Entire vocabulary is coming over here is 5. Here m equals to how much? I think 10, right? We have 10 classes and n equal to 5. Okay, so whatever, now you got that is the vocabulary. So as high it is, it may be 20,000, it may be 10,000. Okay, you will have to add that, and that's how we will calculate the probability. And prior probability also we can calculate equal to C equals to 1. So I will not write it down here. Space is also not there, and you see we have not done anything. There is no smoothing is required in this parameter, because the number of male has not changed, and then prior probability will remain. Prior probability of the class will remain as it is. This is I wanted you to note it down. That's why I deliberately wrote and now erasing it. And here no concept of Laplace smoothing. Okay, so that's how we have recalculated the probabilities of both the class for each word. Okay, with Laplace smoothing, and then we will see that how my model works when some males are coming, especially for that testing example, how it will be classified. Okay, so stay safe. That will be in the next class. So unfortunately you'll have to bring next class also the pen and paper. Okay. Wish you all the best. Stay safe. Bye bye.